good day. My name is Dr. Nuraini binti Muhammad Razali, and our team member Wismita and Nur Nasuha. We are from College of Engineering, and our project entitled Efficient Removal of Toxic Batik Dye by Recycled Sludge. Okay, this is the product background. As we can see in figure 1, it represents the influence dye from the various industries. And as we can see, more than 50% the influence of dye come from the textile industries. And for the motivation for our project, first for ZZ Batik, and they are having problem with the treatment of their wastewater after they making their batik, and then the influence just dump to the pond without any treatment. And then for the second one, for Air Kelantan Sdn Berhad, this company have the side product from their water treatment plant, which is Sludge, and this company responsible to supply water to population at Kota Baru. Therefore, the sludge produced every day, daily. So it's abundant in their company. And then to treatment this wastewater, we propose to use absorption process due to the uh, method is more economical, abundance, and also it most availability. And for the problem statement for this research work, is this textile wastewater containing the toxic synthetic dye which can bring negative effect to the human and harmful to the aquatic life. And also for the second one is the constraint using the commercial absorbent, because this commercial absorbent high value, high price, because they need to treat at high temperature, normally around 80 degrees Celsius, especially for activated carbon. Therefore, the objective of this research is to investigate the potential of waste sludge as an absorbent of for treatment of ZZ Batik wastewater. Okay. And for the novelty of this research work, eco-friendly, low cost, and waste to wealth, because we use absorbent from the waste sludge from Air Kelantan Sdn Berhad, and then we recycle this waste for treatment of wastewater from Batik, ZZ Batik Industries. So therefore, we can use low cost for this project, and the benefit of this project, we can reduce waste disposal cost for Syarikat Air Kelantan, because they have to bear the cost to manage their waste sludge. And then this absorbent can be as an alternative for the treatment of real wastewater from ZZ Batik. And here is the sums our methodology. So for the first, we have to prepare the absorbent of the waste sludge by treated with the acid sulfuric, and then we characterize the properties of our absorbent by using ET, FIR, and also SRD. And then after that, we try the efficient removal of our dye by using this waste sludge material as an absorbent. So when we investigate sample from the ZZ Batik wastewater, we got the malachite green and also methyl red is the highest concentration, means that highest component inside sample. And then we try for the both type of dye, and when we got the optimum condition for methyl red and also malachite green, we try this optimum condition to the our real wastewater from ZZ Batik. And then We also investigate the absorption kinetic and also isotherm for our process. Here is the product image. So this is our waste sludge after that we obtained from air Kelantan Sedia Berhad. And for the result from the characteristic, we got that surface area around 89 with the pore volume and pore size as presented in table 2. And in table 1, this is all the component that present in the waste absorbent sludge from the SRF analysis. And in this figure 2 represent all the chemical bonding inside our absorbent. And then this is the blue one is the from the fresh waste sludge. And then the red and green represent the bonding after we use the treatment of the malachite green and also metal red. So this is the batch absorption study for metal red. So from here we got the optimum condition with 0.2 gram of waste sludge, concentration around 20 milligram per liter, pH 4 and at temperature 35 degrees Celsius. We got removal of this metal red is around 98%. And for the second one, we tried for the malachite green, and the optimum condition we got from this experiment research work with the absorbent dosage of 0.5 gram of waste sludge with the concentration of 20 milligram per liter, pH 8 and temperature 40 degrees Celsius. We can remove around 93% at 80 minutes. And then from both condition, we applied for our real wastewater from ZZ Batik. And as we can see, we have 15% differences between the real wastewater and also from the synthetic sample that we produced before. So same goes as malachite green, both around 15%. And the different percentage removal of synthetic dye and also the real wastewater dye. So around 50% was due to the active site of the waste sludge absorbent was occupied by other elements inside the wastewater. Maybe from another dyes such as methylene blue or metal orange. And to increase the result, we propose to increase the more amount or absorbent dosage of the waste sludge, and then we can longer the removal time to achieve 100% of the removal of real wastewater from ZZ Batik. And then here is the absorption kinetic and isotherm. And from the calculation, we got that our process fit to the friendly isotherm, which indicate to the heterogeneous distribution of active site for our waste sludge material or absorbent. And the second one, the kinetic for the MR and MG follows the procedure second order model, indicate the chemisorption sub mechanism. And this is our market survey. We target for sure for company with the water treatment because they have sludge, and also company related to textile industries, especially batik around Peninsula of Malaysia. And then for the costing, as we can see, we can reduce the cost 3 times cheaper, okay, than the commercial absorbent because we just need sulfuric acid for the treatment, and then we free for the raw material waste sludge absorbent from air Kelantan. So we can reduce 3 times cheaper, and this automatically can reduce the cost for the process. Okay, for the publication, this project is successfully done by Vismita, and now she's graduated. Okay, for this last year to 2020, and then this project acknowledge our research grant from UMP RDU 1803184, and especially special thanks to our collaborators Zizi Batik and also Syarikat Air Kelantan. And then this is our conclusion. The highest removal efficiency for methyl red is 98%, and for methylene green synthetic dye was 93%. And when we apply for the real ZZ batik using this waste sludge from air Kelantan, we can obtain around 82% of removal for methyl red and 70% removal of methylene malachite green. And then our process fit with Frederick isotherm and also procedure second order kinetic. And then from our work, we can conclude that this wastewater from batik, ZZ batik can be treated by our value absorbent sludge, which we can recycle this sludge from air Kelantan Sdn Berhad. And then we hope this project can help more to the nation, especially Malaysia, and especially to Negeri Kelantan. And thank you for your watching.